doing, we're going to evaluate the integral given from over the interval square root of 2 to 2. So basically, it has this form t squared minus 1. So it looks like this form, where my 1 is my constant. Since it's just 1, that means our a is going to be 1. So what we're going to do is we're going to let t, in our case, equal secant of theta. We're following this format. And so our dt is just going to be secant theta tan theta d theta. All right, and to do this, we're going to have to change our bounds. So that means that t equals the square root of 2. That means our theta has to be pi divided by 4. And if our t equals 2, then our theta has to be pi divided by 3. Because secant of pi divided by 3 is 2, and secant of pi divided by 2 is square root of 2. So what or secant of pi over 2 is square root of 2. So we're going to do our substitution now and change our integrals from pi, what did I do, pi over 4? Once I always write 2 for 4, so this should have been 4. All right, so it's going to be pi divided by 4 to pi divided by 3. Now I can write dt, I can write it in the numerator, and this is our dt. So substitute that, you're going to get secant theta tan theta d theta. And then for the denominator, our t is secant, so this is going to be secant cubed of theta times the square root of secant squared theta minus 1. Now this just equals tan squared. So rewriting this further, we have secant theta tan theta, and then we have our secant cube theta, and this is just going to be tan of theta. Because the square root of tan squared theta. And tan, we know that its absolute value of tan squared, or tan of theta, but we're either in quadrant 1 or we're in quadrant 3. And tan is always positive, so you can take away the absolute value signs. All right, now that we have that, let's simplify before I move to the next slide. These two tans will cancel, and this part here is just going to be 1 over secant squared d theta. And that's just going to give you cosine squared of theta. So let's rewrite it again. And we have our intervals from pi divided by 4 to pi divided by 3 of cosine squared theta d theta. Now, I'm going to use my half angles for this. So note that cosine squared of theta, the half angle, is 1/2 1 plus cosine 2 theta. So I'm going to substitute again and write this as 1/2 1 plus cosine 2 theta d theta. And now I can integrate, and I'm going to get 1/2, and the antiderivative of 1 is theta, and antiderivative of cosine is sine, so that's going to be 1/2 sine 2 theta from pi of 4 to pi divided by 3. So what that's going to give you is 1/2. And we start with this one. Pi divided by 3 plus 1/2 of cosine 2. So cosine, or it's just sine, sorry, sine of 2 pi divided by 3. And cosine of 2 pi divided by 3 is square root of 3 divided by 2. Then we have minus, so this is a parentheses, we're doing pi over 4. So that's going to be minus pi divided by 4 plus 1/2 and sine, so we're doing sine of 2 pi divided by 4, which is sine of pi divided by 2, so that's going to be 1. So simplifying this further, we're going to get, this is going to be 1/2, and we're going to have pi divided by 12 plus square root of 3 divided by 4 minus 1/2. And that's taken into both of those into account. So when I subtracted these, I put the pi's together. All right, and if you simplify that further, you're going to get pi divided by 24 plus square root of 3 divided by 6 minus 1/4. So basically, this should have been not 6, but this is an 8. And that's it. Thank you. Have a nice day. Bye-bye.